Hello, I'm Mr. Galvez. Thank you for joining me today as I review in the McGraw-Hill My Math Volume 2 5th grade text. And Chapter 12, Geometry, Lesson 2, titled Hands-on Sides and Angles of Triangles. And in this lesson, we will literally be using a ruler to measure the three sides of triangles, and we'll also be using a protractor. That here, I actually cut this one out. I Googled it and had to use a small, the protractor I had was a little bit too big, too large. So I Googled protractors and I printed out a small version of a protractor, and this should do for this assignment. I want to begin by outlining the details of a triangle, which is a very basic notion. The triangle, it's a polygon with three sides and three angles. And each of the sides of the triangle we can measure with the ruler, and we can also measure the angles of the degree of angles of the triangles. Now, if we happen to come across a triangle that has two sides that are equal length, for example, if this is 3 inches and this is also 3 inches, and this one happens to be about, let's say, 4 inches in length. Since these two are equal in length, I may put two small hash lines just like that to indicate that these two are the same length. Okay, and this one, since it's different from those two, I'll just give it one mark. Now, for a later lesson, we're going to find out that if a triangle has two sides of equal length and one that's not the same as the other, this is going to be called an isosceles triangle. And if they happen to all be equal length, for example, if this happens to be 5 centimeters and this happens to be 5 centimeters in length, and this one also happens to be 5 centimeters in length, and they're all the same length, I can give them all 1 slash or 2 slash to indicate that these are all the same measurement. And that's the equilateral triangle. This is isosceles. Equilateral. And the third type of triangle that we may come across today in our measurements is one that has different lengths on each side, each of the three sides. So if this happens to be 3 centimeters, and this happens to be 5 centimeters, and this one happens to be 6 centimeters, so they're all different lengths, I may give each side a different hash amount. So this one can get 1, this one might get 2, and this third one, that's a different measurement, can get 3. Just to indicate that these are all different measurements. If I take out the numbers and you see 1 and a 2 and 3, you'll know that these are different measurements. Okay. So what I have here are 3 triangles for us to measure. I'm going to begin by looking at this blue one over here. I'm going to use my centimeter side. I'm going to measure these to the nearest tenth of a centimeter. And this one on this bottom length is going to go at 5.1 centimeters, 5 1/10 centimeters. 5 1/10 centimeters. This side over here is about 6. This is closest to 6 centimeters in length. And this longer one over here is going to go 8.4, not 8.5, just under 8.5, 8.4. We call it 8 4/10. 8 4/10 centimeters. Okay, so those are the lengths of each side. And since each one is a different length, I give this one mark. That one gets 2. This one gets 3. Okay. Now we move on to this little pinkish salmon colored triangle. I'll go ahead and get with my ruler and line these up to the 0 mark. And this measures down to 4 centimeters even. 4 centimeters on this length. This measurement here will be 4.4 9/10, 4.9, just under 7. No, I'm sorry, 6.7, just under 7, 6.9. Here's it. I'm gonna write 6.9 centimeters. And the longer length over here starts at 0, ends at just under 8. 9/10, 7 9/10. This one measures 7 9/10 centimeters. And last but not least, the angles on the lengths of sides on this white triangle. We're looking at 6 centimeters over here. The side on this side also hits 6 centimeters. And the longer one down here, I line this up just at the end of the ruler. This one goes across 8.5 centimeters, 8.5 centimeters, 8.5 centimeters. Now, those are the lengths of the sides, but when it comes to measuring the angles, then it does get a little more complicated. What we have to do here is pay special attention to how we use a protractor. So if I want to measure this angle, I want to line this edge of the protractor with the bottom line. It gives me that 0 0. And what's going to give me the measurement is this section here. Let me see if I can zoom into a little bit. Okay. This section here, and I'm reading 90. So this angle here is saying 90 degrees. If we look at this angle over here, to make it simple, let me try to just label these angles A, B, and C. Angle C measured 90 degrees. Angle A, I'm gonna get that protractor over here. I'll line this up flat on this side, and I'm coming over here, and it's looking like it's between 20 and 30. Between 20 and 30, about 25 degrees. Angle A is 25 degrees. And put a little circle right there to indicate degrees. Angle B let's see what we have for angle B. I'll line this flat edge. The vertice point of the triangle goes to the center point, and here we're looking at between 50 and 60. Between 50 and 60 degrees. I do have about 130 and 120, but that's going over. That's too much. It's the angle measurements start at 0 and it goes to 10, 20, 30, 40, 50, 60, 70, 80, 90. If it's all the way open, like a straight line, it's 180. 180, we're not that close. We're not close to 180. We're closer to between 50 and 60. We'll call this 55 degrees. Angle B measures 55 degrees. Okay. And now for the white triangle over here, we'll start by measuring this angle over here. Align this over here. And this angle is going to go from this straight line to this one up and down. I'm going to go across 0, 10, 20, 30, 40. Here's at 90 degrees. Let me label these angle A, angle A, angle B, angle C. Angle A was 90 degrees. Angle B is going to be less than 90, I can tell already. Less than a square angle. Here I'm going to go from 10, 20, 30, 40. 40, between 40 and 45. Between 40 and 45, I can call it 42. Angle B measures 42 degrees. And angle C is another closed angle. What we're going to call a acute angle, smaller. Let's start by getting this lined up over here. And this angle over here. I see 140 and I see 40. I see 40 and 140. I see 40 and 140. But I know this can't be over 100. It can't be over 90. So I'm going to go with the 40 degree measurement. 40. 0, 10, 20, 30, 40. Angle C measures 40 degrees. Okay. And so that's the gist of the lesson, measuring the lengths of triangles and measuring the angles of the triangles. You will need a ruler. The book does come with a handy small ruler that you can cut out. And for a protractor, if you can't find one in your textbook, you can do what I did. Go to Google, go to images. I clicked an image, I pasted it onto a Word document, and I shrunk the protractor because the ones that come out in the Google images are a little bit too big for this assignment. So I shrunk it down to this size, and one to this size, and one to this size, about two or so inches long. And that was enough to be able to allow me to do this assignment. Once again, lesson 2, hands-on size and angles of triangles in the geometry chapter of the Mind Math text. Thank you for tuning in. I'm Mr. Galvez.